Welcome to the Beacon session at Build 2016. Last year at Build, we presented an entire session dedicated to beacons. It was our new API for last year. And we presented concepts of the advertisement watcher, which looks for nearby beacons, and the advertisement publisher, which actually makes Windows the beacon. We also showed an extension of, in order to give users extra context, through a cloud service like Azure. This time at Build, we wanted to extend those same concepts and to actually interact with the beacon itself. Hi, my name is Kiran, and I'm a program manager on the Windows Bluetooth team. And this session is Beyond Beacons, Proximal Awareness with Bluetooth LE. Well, first things first, we need to go into what is a Bluetooth LE beacon. If you attended last year, or if you saw the session online, you'll know that a beacon makes use of the advertisement packet that is present in all Bluetooth Low Energy devices since Core Spec 4.0. The beacon makes use of a unique payload in order to give nearby devices extra context. And usually that context is proximity and presence detection. The other cool thing about beacons is that anything can be a beacon. Well, anything that uses Bluetooth Low Energy. So Windows can be a beacon as well. So check out our publisher APIs for more information on that. In this particular demo, we wanted to be able to connect back to a beacon that's broadcasting. There are three things that are going to go into this demo. This Lego piece, which is the Lego We Do educational kit, that will be our beacon. So it supports Bluetooth Low Energy, and when you press this little green button, it starts beaconing. When our phone picks up a beacon advertisement that is close by, we want it to connect back to the Lego and interact with it. And what better way to interact with a Lego than to make its motor move? So those are three things that we will show by listening for nearby packets, interpreting that we are actually talking to a Lego device, and then you could alert the user through a toast, or in this case, we're not really going to alert the user specifically. And then you can communicate back with the beacon. In this case, we're going to use Bluetooth Low Energy because that's what the Lego supports. But really, this is an area that you can totally innovate on. Use any transport like Wi-Fi Direct or local area connection, anything really. So communicate over your preferred transport. Again, this demo is going to use Bluetooth Low Energy. So we have a couple of pieces to make this all work. When the app registers a beacon, a Bluetooth advertisement watcher trigger, so it's registering to look for a specific pattern in the beacon payload, the system is going to take that and start looking for that pattern on the app's behalf. So we actually communicate the pattern that you're looking for directly to the controller on many devices. So, and that feature is called hardware offload. So we hardware offload the pattern that you're looking for, so it takes up as little battery as possible. When the controller finds a filter that matches the advertisement that the Lego is beaconing, it notifies Windows that there is a beacon around that satisfies your requirements, and in turn, Windows will invoke your background task, the app's background task, so it can respond to a beacon being present. Once your background task is invoked, you can get the Bluetooth device from the address that is being beaconed. This doesn't work for all devices. It really only works for devices that don't implement LE privacy, don't randomize their address. But the Lego, being a toy, advertises its Bluetooth address in the clear. So we capture that, create the Bluetooth device, and once you have a Bluetooth device in your background task, you can start GAT communication over LE. All right, so those are the components. Let's see it in action. Let's jump into Visual Studio, and I'll show you how we coded this up. Now that we're in Visual Studio, I'll show you how we created the Beyond Beacons demo. The first step was to initialize the trigger. And this tells the system what types of advertisements we're looking for and at what sampling frequency. In this case, we're actually using a range filter that is quite lenient. So we will be getting advertisement packets for devices that are quite far away. We also choose a sampling interval that of about 2 seconds. So from a particular device, we will get a beacon payload every 2 seconds. The out of range timeout determines how long it takes to stop receiving beacon advertisements, provided that you've gone out of range. So if the system sees that the beacon is advertising at less than the out of range threshold. So let's say I've started walking away from the Lego, and the RSSI, the received signal strength on the phone, drops down below 90, below negative 90. We will wait 5 seconds in the current configuration in order to stop firing the background task. So if the beacon goes to, we start receiving beacon advertisements at like minus 95, we'll still bubble that up to the user. So we'll give you that in the background task. However, if it's below minus 90 for 5 seconds, then we'll stop receiving advertisements in the background task. OK, so we've configured an advertisement filter based on proximity. I'm not going to go into how to register a trigger, but once you call builder.register, your advertisement is being proactively looked at by the system. When the system receives an advertisement packet that conforms to the filter that you configured the initial trigger with, we will fire the background task. And you cast the trigger details as the specific type, the Bluetooth LE advertisement watcher trigger details type. And that allows you to read the event args property. The property of the trigger details gives you a list of Bluetooth advertisements that you get in the background task. Now, we give you a list and not just one advertisement because there's a chance that in the sampling interval, you've received multiple advertisements from different devices that conform to the same filter, in which case we bundle those advertisements together, and as a developer, it's up to you to unpack them and step through all the advertisements. In this case, I know that I'm just looking for one device, so I'm just going to take the first advertisement packet, and in order to get the device, I know I'm going to have an async call to the from Bluetooth address async, so I make sure to get the task deferral. The key thing here is I've been very lenient with my background task, configuring the proximity filters, but I really want my phone to only trigger the beacon when I'm really close by. So I'm going to configure a far more aggressive minimum RSSI that actually causes the device to get connected to. So that means that the background task is going to fire multiple times, just showing that you are in the vicinity of the device, but it's only going to connect to the device when we cross a certain minimum RSSI threshold. All right, so once you get the Bluetooth device, we write a characteristic value to it, and We have another session on how to communicate with the Lego WeDo 2.0, but what you can basically do is write to a particular characteristic value, and it changes the motor speed. So we do that, and then we keep our task alive for a couple seconds to allow time for the motor to spin, and then we call dispose on the Bluetooth device object. And what that does is, if that is the only handle that the system has to that device, the device will get proactively disconnected. So if multiple apps on the system are accessing the same device, different services on the device won't get disconnected if one of the apps calls dispose. But in this case, since I know the Beyond Beacons demo is the only app on this, is the only app that will access the device on my phone, when I call dispose, that's actually disconnecting from the device. And completing the deferral will stop the background task. Because it was an async call to do the background communication with the beacon, we had to get the task deferral. And calling complete will let the system know that your background task is done with all of its operations. I have here the beacon proximity demo on my phone. And I'm just using Project My Screen to cast it onto my laptop. So let's start by registering a background task. And I've tapped on the button to register the background task, telling the system to look for beacons that satisfy a particular filter. Once that is done, I'm going to beacon from the Lego. So that's going to start the beacon. And when my phone sees the beacon, it connects back and starts the motor. If I remove my phone away from the Lego, it's going to stop rotating. When I bring my phone back, the RSSI value crosses the threshold, and then the motor spins again. And this will keep happening based on proximity. And that is Beyond Beacons. Maybe I have to go further away. This is a small studio. All right. We tuned it to be pretty aggressive. All right. Thank you so much for watching. That was the Beyond Beacons demo. And I hope you learned a little bit about using Bluetooth for proximity in the background. For this code sample, as well as other demos like this, as well as complete reference to our other Bluetooth APIs, please check out our Bluetooth landing page at aka.ms/btdevdocs. Please check out all the other awesome build sessions on Channel 9 as well, and continue your learning of this technology area and a lot of the other ones on the Microsoft Virtual Academy. Thanks for watching. Goodbye.